this is the last section of the chapter.
Our chapter test is Friday.
Yep. So tomorrow we're having a quiz on 2.5 through 2.8. Okay. Wednesday I will give you class time to work on the chapter review for chapter 2, which will be extra credit on the test. If you want extra credit on the quiz for tomorrow, you need to have CK12s for 2, 5, 6, 7, and 8 complete before class tomorrow. And Thursday then we'll go through the review in class, and Friday is your chapter 2 test. We have this week and next week, and that's the end of the quarter. Next Friday.
Wait, what? Really?
Yes.
Wow.
Next Friday, October 12th, is the end of the quarter. I know. So if your grade's not where you want it to be, you might find some time to come in and work with me, retake some quizzes. You have 2 weeks to get your grade up.
I won't be here the 10th.
Okay. I won't be here the 11th and 12th.
Where are you going to be?
My mom's memorial is Saturday the 13th.
I'm so sorry.
Okay, so this section, this last section, okay, let's put that away now if we can. And I'm going to start something. I think while I'm talking, everybody turn your computers facing out. That way you don't have to close them and restart them, but then I know you're actually paying attention to me. Okay. Except if you're Jaron, just leave it facing in.
Jaron, turn your computer around.
Oh, turn it in.
I meant facing in. Did I say I? Yeah, facing in. Okay. Because, you know, for 10 minutes a day, I like to be center of attention.
That's all right.
So this section is the section in this chapter where everybody says, what's the purpose of math? This is the purpose, this section. This is why we learn how to find the equations of lines. When you are in the real world and you're getting data for whatever, whether it's in a science lab or, well, science lab's the best example, and you're getting data, okay, the data is never, rarely, probably never, going to be in a perfectly straight line or a perfect parabola or a perfect V. It's always going to be scattered. Okay, and so what you do as a scientist is you draw your x and y axes and you draw your data points and you look at them and try and decide, is it closely related to a line? Is it closely related to a parabola? What is the equation of best fit for this line? And the reason you do, let's say you're studying the Ebola virus and you have 4 or 5 different cases, and you've got maybe the time that you found them, the location, whatever, and you plot this on a graph. You want to be able to make predictions on what's going to happen in the future based on your data set. Okay, and if over the course of a day, this virus multiplied 2 or 3 times, you want to know how long before the virus multiplies and takes the whole world out. How many days is that going to be, or how many weeks, or how many years? So you want to be able to use your data set to make predictions in the future. That's the point of scatter plots. If you can get an equation, and in our case for this section it's of a best fit line, if you can get the equation of the line, you can make predictions for data that's outside of your set that might be in the future. Maybe time, 2 or 3 years down the line. Okay? So there's 2 ways to do this. The first way is manually, and the second way is with a graphing calculator. Okay, so let's talk about manually first. If I were to create a data set, if my starboard would load. Okay. And let's just say I have a data set like this. Okay, it does have a positive slope, okay, or correlation. That's sometimes what we call it with scatter plots. It's got a positive correlation if the slope is positive, a negative correlation if the slope is negative. Okay. It also kind of seems like it could be a line versus a absolute value function or a parabola or something else. I could maybe approximate this as a line. So the first step that you do is you're going to just draw a close-fitting oval around your data set. Okay? You're going to find a point at the end of each side of the oval.
Does it matter?
Well, you just want one where the oval kind of comes to the smallest point, not a point, but circle. And I'm just going to connect those 2 points. This is how I'm just going to approximate the line of best fit. Okay? So you don't necessarily need to use one of the points you're given. Okay, sometimes one of the points you're given is on your line. Sometimes it's not. Okay? So I just drew an oval and I just approximated my line of best fit. Okay? From here, I'm going to look at my graph and see if I can find a place where this line goes through an actual coordinate. And it's not looking very good. If I keep going, I'll call this a point. And let's see if I can find another one. It's close to this one, so I'll call this a point. Okay, so I'm going to use these 2 points now to find the equation of the line. Okay, this coordinate is 1, 1. This coordinate is 1, 2, 3, 4, negative 4, negative 5. Okay, now we're going back into the chapter on finding the equation of a line when you're given 2 points. The first thing you do is find the slope. So 1 minus negative 5 is 6. 1 minus negative 4 is 5. So my slope is 6/5. To find b, I'm just going to put one of these points back in for x and y. Okay, and I'll subtract. So this is 5/5 minus 6/5 is equal to b, which is negative 1/5. So the equation of my best fit line is 6/5 x minus 1/5. Okay, now once I've got my equation, if someone says, well, what happens when x is 200? All I have to do is plug in 200 for x and I can tell you what y would be, approximately. It's not an exact science. Okay, and when we're doing the same data plot, everybody's doing the same one, everybody will probably come up with a different equation. It'll be close, but it's not going to be the same because you're going to draw your oval a little more skewed or less skewed than mine. When you connect the lines, maybe one of you uses a ruler and one doesn't, like me. You know, so there's lots of places for precision to decrease. Okay, but the idea is you're going to get approximately the same line, and then you can use that data or that line to predict things in the future. All right, take out your calculator that I handed out, and let's do maybe a problem from the textbook here. Okay, so let's do this first one. What you're going to do, those of you who didn't watch the video, hopefully everyone did, because the video went through the steps necessary to do this. But you're going to go to, I need one of my own so I can talk you through this. You're going to go to Stat, and then Edit. So just hit Enter, and you should have a list. At the top of it, it should say L1 and L2 and L3. Yours might say L4, 5, and 6. It doesn't matter. You're going to be creating the 2 columns. The first 2 columns, the first one will be your X. The second one will be your Y. If you already have data in a column, arrow up where L1 or the very first column is highlighted, and just press Clear and Enter, and all of that data disappears. Okay, so what I want you to do in the first column is, what do I want to do here? Let's pick a different set of numbers. What did they do? 5, 7, 8. No. Let's do this one, this scatter plot. So let's make 1990 be year 0. Okay, so 1990 is 0, which means 91 is 1, and 92 is 2, and so on. So you're going to type 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in your first column. 0 through 10. Okay? Your second column, you're going to type these numbers, and if you can't read them, I'll read them to you. So across from your 0 should be 3317. Across from 1, 3383. Across from 2, 3038. Across from 3, 4030. Across from 4, 3306. Across from 5, 4081. Across from 6, 4962. From 7, 4640. From 8, 5064. I did that wrong. From 9, 5064. From 9 is 5528. And from 10 is 5693. Okay, if we were doing this by hand, we would graph this on graphing paper. We would draw our oval, we would connect the ends of the oval, and draw our line of best fit through this data set. On a graphing calculator, what you're going to do is first go to y equals, that's the top left button. If there's an equation there, hit clear, so it goes away. Now go second y equal, and it says stat plots at the top. Does everybody see that?
Yep.
Okay, go down to the first, it's highlighted, hit enter, and right now mine is turned off. So just hit enter on so that it's turned on. Okay, we can then go through and look at the different kinds of plots we want to type. I'll just highlight the first one is fine. And you see where it says X list and Y list?
Yeah.
Okay, so you want to go into stat and make sure your first column is L1 and your second column is L2. If for some reason your stat starts at L4, then you would want to change this list to L4 and L5. But if everybody's on L1 and L2, then we're good. Okay? Now you're just going to hit graph. And is anything coming up?
No,
No. Well, why do you think that is?
because nothing was plugged in.
No. We had the two lists. What's the scale
Catherine has something.
of our graphs? These little dashes represent 1 unit.
4, 5,
So this is a 10 by 10 window.
right?
Okay? We had our first data point was 3,317. It's probably not going to be in this window.
Probably not.
Okay? So we need to change our Y scale. Okay? So that maybe it starts at 3,000 and goes to 6,000. Okay? To do that, you're going to go to Window. And under Window, you see how Xmin and Xmax are there at negative 10, 10.
Or I have -5.
Okay, well you might make yours, let's make it -1, and let's go out to 15, just so that, because 10 is the very last data point, and if we put 10 at the very last, you might not see that point, so we'll go to 15. Now let's go to the Y. Let's make the Y min 3,000, and the Y max 6,000.
Okay.
Now graph.
Ooh.
Do you see your data plots or your points in there? Do you see, what is the correlation? Is it positive or negative? Positive, huh?
What was the Y max?
6,000.
Right.
That's not right. I don't think.
Okay, so if I could graph this on graph paper and then do the oval and do everything I just did, but I can also use the calculator to tell me what the line of best fit is. Okay, to do that, you go back to stat, go to the right where it says calc, and these are all the different, like we have a linear regression, we have quadratic, we have cubic, we have quartic, so you kind of match up what the look of the line is. It looks like it's a line, so I'm going to do linear. Okay, so go down to number 4 and hit enter. And it says X list L1, Y list L2. That's what I want. You're going to go down to calculate and hit enter. And it gives you
Oh.
Y equals mx plus b, except m is a now, and b is b.
267 equals M.
Stat.
2939.545455454545.
Wait, I can't get that.
Yes, you
So
can.
the
Don't
stat-
you worry.
And then-
Calc, linear
Stat,
regression,
Calc and
L1, L2,
Whoa, what'd you do?
calculate.
Exactly.
I don't know why it says invalid dimension here.
Y equals, no, we're not going to go there. We're going to go,
Show me.
I may have to change the format or something on yours.
Yeah, my screen, I did not get that.
Okay, So use this one and go to Calc.
Press enter again.
I didn't
Alright,
get
so
it,
as soon as-
just got over here.
Yeah. So you put
Oh.
18 in,
Let me see.
You've got 0 through 10.
Let me see.
Why did your data go away?
That's exactly what I got.
You just found it.
Yeah.
That's what I got.
So that,
Oh, that's what I got too.
yeah. So A and B are all you worry about. If yours came up with an R squared or an R, don't worry about that. A and B are all you're worried about. And so the equation of this line would be y equals 269.4x plus 2,935 if we round it up. Okay, so that the calculator found the equation of our line without us having to do any more work than that.
Mrs. Rieger, she doesn't have R2 or R.
It's okay.
Okay.
Right now, that's all we care about is just A and B. Steve, did you get it? Okay. Ian, did you get it with that one? Okay. So this is how we use the graphing calculator to find the equation or the line of best fit. Okay, so if you're still a little fuzzy on this, it might help to practice because you're going to be using that for web work.
In the test. Oh,
Yep. Okay. Okay, so let's go through the textbook check. I went back here.
Can we flip our computers around?
Yes, flip your computers around. And this is 2.8. Everybody cool off enough?
Oh, yeah. Here.
Okay, question 1. When estimating a best fit line from scatter plots without a calculator, after you have sketched a line, you need to find 2 points. It is blank that these 2 points are included in the original data set. Not important. You just want to find 2 points that are on the line you sketch in. Okay? This graph, or these graph, apparently I can't spell the word this, appears to have a negative correlation or positive correlation, or negative reciprocity or positive interconnection, negative correlation, because the slope is going down from left to right. To make a scatter plot using a graphing calculator, you first need to enter a list of data. What button do you press? Stat. Good. Scatter plots almost always represent real-life situations. True. What is the purpose in finding a line of best fit? You can predict future values. Okay? All right, so go ahead. Web work 2.7 is due tonight. 2.8 is due tomorrow night. And then tomorrow we have a quiz. So don't forget to get your CK12 done.